Assalamualaikum and good day everyone. We are now in the second to the last chapter of our video lecture discussion. Now for this chapter, we are going to tackle ERP or the Enterprise Resource Planning System. The learning objectives for this chapter: after studying this chapter, you should be able to understand the general functionality and the key elements of ERP system, the various aspects of ERP configuration, including servers, databases, and the use of bolt-on software, as well as the purpose of data warehousing as a strategic tool, and recognize the issues related to the design, maintenance, and operation of a data warehouse. You should be able to recognize the risk associated when implementing ERP, and the key considerations related to its implementation. And lastly, to be able to understand internal control implications associated with the ERP system. The topic outline for this chapter. As for the part 1, I will be introducing to you what is an ERP system and the ERP system configurations, followed by Muhammad Hafid Inserad for the data warehousing and the risk associated with the ERP implementation. And lastly, we have Marjana Pagayawan for the implications for internal control and auditing and the overall summary for this chapter. The following are the key terms for this chapter. Now, what is ERP? The term ERP was coined by Gartner Group. Before the ERP was created, there were already other organization systems that were created. No? We have the system just for inventory control, the MRP or the material requirement planning, the MRP2 or the manufacturing resource planning. Just recently, most companies, especially those large and mid-sized organizations, they design and program their information system in-house. Although effective siya although those systems are effective with their designated task, they did not provide a strategic decision support at the enterprise level because they lack the integration needed for an information to transfer across organization boundaries. And dyan na-create yung ERP system which attempt to integrate all the functions across a company into a single computer system that can serve all those functions' specific needs. Enterprise Resource Planning are multiple module software packages that evolved primarily from traditional manufacturing resource planning system. ERP is an IT software that integrates business activities across an enterprise. Now, the main objective of the ERP system, again, is to integrate key processes of the organization, such as the order entry, manufacturing, procurement and accounts payable, payroll, and human resources. In the ERP system, a single computer system can serve the unique needs of each functional area or each department of an enterprise. Designing one system that serves everyone is an undertaking of massive proportions. Compared to the traditional model system, each functional area or each department has its own computer system optimized to the way it does its daily business. And these computers do not communicate with each other when there is an update of the status of an, for example, customer order. Sa ERP system, the ERP system combines all of this into a single integrated system that accesses a single database to facilitate the sharing of information and also to improve communications across the organization. Like for example, with the customer, for example, in this figure given, when the customer places an order, the order begins in a paper-based journey around the company where it is keyed and rekeyed into the system of several departments. Since yun nga, sa traditional model system, separate yung computer system kada department, nangyayari, for example, customer order, paulit-ulit siya ini-enter kada computer system. And because of that, this redundant task, it may cause delays and loss of orders. And mayroong possibility din na may data entry errors. Since paulit-ulit siya, hindi may iwasan na may magkamali while encoding the, for example, the order. During transit through the various system, the status of the order may be unknown at any point in time. For example, responding to a customer query, the marketing department may be unable to look into the production database to determine whether the order or whether that order has been manufactured and shipped. Instead, ina-advise na lang nila yung customer to call na tumawag sa manufacturing department. Katulad din, for example, sa procurement of raw materials from suppliers. It is not linked to the customer orders until they reach the manufacturing stage. And those scenarios results in delays because manufacturing awaits the arrival of needed materials or in excessive investment in inventories to avoid stockouts. The ERP or the Enterprise Resource Planning System functionality falls into two general groups of applications. We have the core applications and the business analysis application. The core applications are those applications that operationally support the day-to-day activities of the business. Now, if this application fails, so does the business. The core application is also known as the Online Transaction Processing or OLTP. Now, the typical core applications include but are not limited to the following given: sales and distribution, business planning, shop floor control, and logistic. Under the sales and distribution functions, this department handle order entry and delivery scheduling. It also includes checking on the product availability para ma-ensure yung timely delivery of the customer order. And it also verify the customer credit limits. Unlike dun sa traditional information system, sa ERP system, the customer orders are entered only once. Since all users access a common database, the status of an order can be determined at any point in time. In fact, the customer can also check their order directly via an internet connection. And with that integration, it reduces manual activities, it saves times, and decreases human error. While the business planning consists of forecasting demand, planning product production, and detailing routing information that describes the sequence and stages of the actual production process. Now, the capacity planning and the production planning can be very complex. That is why some ERP system provide simulation tools that helps a manager decide on how to avoid shortages, for example, in materials, labors, or plant facilities. Now, once the master production schedule is complete, the data are entered into the MRP or the Material Requirements Planning, the MRP module. And this provides three key pieces of information. We have the exception report, the material requirements listing, and the inventory requisition. Under the exceptions report, this report identifies the potential situation that may result in rescheduling the production. For example, there is a late delivery of materials. While the material requirement listing, it shows the details of vendor shipments and the expected receipts of products and components needed for a customer order. While the inventory requisitions, it is used to trigger material purchase orders to vendors for items not in stock. For the shop floor control involves the detailed production scheduling and dispatching and job costing activities associated with the actual production processes. And lastly, the logistic application. For the logistic application, this application is responsible for ensuring the timely delivery of the customer orders to the customer. It consists of the inventory and warehouse management as well as the shipping of those orders. Most ERP systems also include in their system the procurement activities within the logistic function. ERP functionality is that ERP system is also a business analysis application, or also known as the Online Analytical Processing, or OLAP. Aside from the ERP system helps the organization from processing their day-to-day activities, or the processing system of that organization, it is also a decision support tool that supplies management with the real-time information and permits timely decisions that are needed to improve the organization's performance and achieve competitive advantage. This online analytical processing includes decision support, modeling, information retrieval, ad hoc reporting or analysis, and what-if analysis. There are some ERP systems that support this function with their own industry-specific modules that can be added to the core system or the core application. There are some ERP vendors that designed their system to accept and communicate with specialized bolt-on packages that third-party vendors produce. Sometimes the user's organization decision support requirements are unique that they need to integrate in-house legacy systems into their ERP system. However, business analysis applications are obtained or derived. They are central to their successful function as a data warehouse. A data warehouse is a database constructed for quick searching, retrieval, ad hoc queries, and ease of use. This will be further discussed for the second part of this video lecture. Uh, Sa data warehouse, the data are normally extracted periodically from an operational database or from a public information service. Now, the ERP system could exist without having a data warehouse. Likewise, organizations that have not implemented an ERP may deploy a data warehouse. Uh, yung trend ngayon is most organizations that are serious about competitive advantage, they deploy both the ERP system and data warehouse. The recommended data architecture for an ERP implementation includes separate operational and data warehouse databases. This data warehouse will be further discussed in the second part of this video lecture. Let us now proceed to ERP configuration. ERP configuration deals with the system components, but not on the organization or the business process needs. Configuring the organization's system components allows them to work within a given environment constraint. This means changing the parameters that meet your business or the organization's financial, language, shipping, and customer-facing needs. For the first part of ERP configuration, we have the server configuration. Now, in the ERP system, they are mostly based on client-server model. A client-server model is a form of network topology in which the user's computer accesses the ERP programs and data via a host computer called the server. Now, these servers may be centralized, but the clients are usually located at multiple locations throughout the enterprise. There are two basic architectures. In the client-server model, we have the two-tier and the three-tier model. As shown in the first figure, the two-tier model is a server, or the server in the two-tier model handles both the application and the database duties. Here, the client computers are the one responsible for presenting the data to the users and passing user input back to the server. There are some ERP vendors who use this approach for a local area network applications for which the demand on the server is restricted to a relatively small populations of users. While the three-tier model in the second figure, the database, as you can see that the database and the application functions are separated. In this architecture, They are typically used in a large ERP system that use wide area networks or WAN for connectivity among the users. Now, satisfying the client requires two or more network connections. Initially, the client establishes communication with the application server. Now, the application server then initiates a second connection to the database server. In the two-tier database, uh, they are a client-server architecture, while a three-tier database is a web-based application. Sa two-tier model, it consists two layers. We have the client tier and the database tier. While sa three-tier model, we have three layers: the client layer, the business layer, and the data layer. Sa two-tier model, it is easy to build and maintain, while sa three-tier model, they are complex to build and maintain. But they are faster, they run faster compared sa two-tier model. Sa two-tier model, they are less secured as the client can communicate with the database directly compared sa three-tier model, which is mas secured siya since the client is not allowed to communicate with the database directly. If an organization both deploys ERP system and data warehouse, there is a need of clear distinction between these two competing types of data processing, the OLTP versus the OLAP servers. The OLTP supports mission-critical tasks through simple queries of operational database. In the OLTP events, it consists of large numbers of relatively simple transactions, such as updating the accounting records that are stored in several related tables. For example, an order entry system retrieves all of the data relating to a specific customer to process a sales transaction. Now, only the relevant data are selected from different tables: in the customer table, in the invoice table, and detailed line item table. Now, each of this table contains an embedded key. For example, a customer number that represents a single customer, which is used to relate rows between different tables. Now, the transaction processing activity involves updating the customer's current balances and inserting new records into the invoice and line item tables. The relationship between the records in such OLTP transactions are usually or generally simple, and only a few records are actually retrieved or updated in a single transaction. For the OLAP servers can be characterized as online transactions that can access a very large amount of data, like for example, the sales data from several years ago. It can analyze the relationships among many types of business elements, like for example, sales, products, geographic regions, and marketing channels. It can compare aggregated data over hierarchical time period from monthly to monthly basis or quarterly or in a yearly basis. It responds quickly to users' requests so they can pursue an analytical thought process without being stemmed by the system delays. It also involves aggregated data such as sales volume, budgeted dollars, and dollars spent. It also involves complex calculations among data elements and present data in a different perspectives. An example of an OLAP transaction is the aggregation of sales data by region, product type, and sales channel. May need to access a vast amount of sales data over a multi-year period to find the sales for each product type within each region. Now, the user can further refine the query to identify sales volume by product for each sales channel within a given region. And finally, the user may decide to perform a year-to-year or quarterly comparison for each sales channel. The OLAP application must be able to support this analysis online with a rapid response. For the OLAP servers, this application supports common analytical operations, including consolidation, drill down, and slicing and dicing. For the consolidation, it is the aggregation or the roll-up of data. For example, in a sales office, the data can be rolled up to districts, or districts can be rolled up to regions. While the drill down permits the disaggregation of data to reveal the underlying details that explain a certain phenomena. For example, the user can drill down from the total sales return for a period to identify the actual products returned and the reasons for their return. While the slice and dicing, this enables the user to examine the data from different viewpoints. For example, the one slice of data might show sales within each region, while the another slice may present sales by products across regions. Slicing and dicing is often performed along a time axis to depict trends and patterns. The OLAP server allows the users to analyze a complex data relationships. The physical database itself is organized in such a way that related data may be rapidly retrieved across the multiple dimensions. Thus, the OLAP database server need to be efficient when it comes to storing and processing the multidimensional data. To summarize, the online transaction processing applications support mission-critical tasks through simple queries of operational database, while the online analytical processing applications support management-critical tasks through analytical investigations of complex data associations that are captured in the data warehouse. Both have a specialized requirement that are in direct conflict. As shown in this figure enables the organization to deploy a separate and specialized application and database servers to resolve these conflicting data management needs. For the database configuration, it is used to create or change objects and attributes, and also to customize the database. In the ERP system, it is composed of thousands of database tables, and these are associated with the business processes that are encoded into the ERP system. Now, when the organization are implementing their ERP, they select a specific database tables and processes by setting the switches or adjustment in that system depending on the set of the given configuration or on how they wanted to formulate their system. But it requires a deep understanding of the existing processes and used in the operating businesses. Kaya kadalasan ang nangyayari while the ERP team are choosing table settings involves a decision to re-engineer the company's process para mag-comply siya dun sa best practices used in the business. In other words, the company typically changes its processes para ma-accommodate yung ERP system rather than modifying the ERP system to accommodate the company. The third ERP configuration is the bolt-on software. The ERP system alone cannot accommodate all the companies all the processes in a company. That is why different organizations use a variety of bolt-on software that third-party vendors provide. This bolt-on software provides a supplementary function that the core ERP system cannot give. But the decision to use a bolt-on software requires a careful consideration because it may complicate the user's experience, duplicate the existing feature, and it also use a different interface and may create gaps in the business security posture. But most ERP vendors are now entering into an agreement or partnership with the third-party vendors of bolt-on software to provide a specialized functionality to their ERP system. But it is best to choose bolt-on software that are recommended by the ERP vendor. But there are also some organizations who take a more independent approach in choosing on what bolt-on software to be added to their core ERP system. Just for example, the Domino Pizza Incorporation. It is an American multinational pizza restaurant that distributes millions of pizza around US. In an average, they manufacture around 4.2 billion pounds of dough per week and are distributed to their franchise. However, this company has no cut-off time for ordering supplies. The franchisee can call and adjust their order even after the truck has already rolled away from the distribution center. That is why this company uses different bolt-on software such as the Present System Incorporation, the Majestic Incorporation, Kronos Incorporation, and the Cognos and Hyperion Solution Corporation system. Even before the ERP system was implemented in their company, these systems are already used in the Domino Pizza Incorporation. The Present System Incorporation helps the company anticipate demand, and it is used for forecasting demand. They also use the Majestic Incorporation to schedule and route their delivery trucks. Each truck has an onboard computer system that feeds data into a time and attendance system from the Kronos Incorporation. Aside from that, the company also has an extensive data warehouse. And to anticipate its market, Domino's performs data mining with the software from Cognos Incorporation and Hyperion Solution Corporation. And they had been using this software or application before it implemented their ERP system. They don't want to retire this existing application, but they find it helpful to integrate it with their ERP system, since the ERP system cannot give or provide the following functions that these softwares can give. Another development in the ERP system, aside from the rapid convergence between the ERP system and the bolt-on software, another good example also is the supply chain management system or the supply chain management softwares. These are a class of application software that supports tasks in a supply chain, such as procurement, production scheduling, order processing, inventory management, transportation, warehousing, customer service, and forecasting the demand. These are sets of activities associated with moving goods from raw materials stage to the customer. Through the supply chain management software or the application, it links the vendors, the carriers, to the third-party logistic companies and information system providers. By that, the organization can work more efficiently and effectively by linking their activities in its supply chain. Recognizing these needs, ERP vendors are now adding the CSM module to their system. Likewise, the ERP or the CSM companies are now expanding their functionality to appear more like ERP system. Just like, for example, the PeopleSoft has now acquired smaller CSM vendors to integrate its CSM software into their future releases. And also the SAP and Oracle company, they recently added CSM module in their ERP system.